Hello, my name is Oscar Duran. I'm in the Geomatics Engineering Master's Program at the California State University, Fresno. And this research is titled A Comparative Analysis of Software Used to Process Drone Imagery. The accessibility and relative ease of use of drones has had a great impact in many industries, such as real estate, agriculture, environmental monitoring, and mining. The mapping industry has been revolutionized by the introduction of drones as an alternate platform for photo capture. Normally, photos are collected from airplanes and processed to produce 3D models, and from them a wide variety of mapping products can be derived. Now, drones are able to accomplish the same, and the software used by drones to process images are characterized by high automation and ease of use. The simplicity of drones, however, makes them greatly appealing to a wide range of users, but this may often lead users to undermine the limitations of drones in 3D modeling. And this may raise an interesting point, and perhaps an issue as well. Now let's look at how society adopts innovation. Everything around us is functional, it's practical, from our clothing to furniture, to our cell phones. In the past, you used to have to carry an agenda to organize your schedule, but today, everything is contained in your mobile device. Everything has been simplified for you, a one-button solution. And aircrafts have gone through the same evolution. We have seen how airplanes have gone from large aircrafts to very small drones, from being operated by a professional to a kid who can quickly make use of a drone with the click of a button. It is quite amazing how they have evolved, from a very large apparatus to such a small device. But then you look at the cost. How drones today have been made so much more affordable. Virtually anybody can get their hands on a drone. But more than anything, I want to emphasize expertise. Because the expertise that is required for operating an airplane is definitely not the same that is required for a drone. And this has led to a premature adoption of drones in the mapping industry because of their simplicity. Before continuing on, I would like to discuss the following. How did this research begin, and why is this an important topic? Let me give some context. The Fresno State University campus is located in the Central Valley of California, one of the most productive agricultural regions in the world, a prime candidate for drone surveys. Before beginning this research, I was having a conversation with Dr. Yusin An, my advisor, and he said many local drone users have been asking about the accuracies of drone processing software when compared to aircraft software. And then he went on and said something very interesting. He said, we, as subject matter experts, should be the ones to answer and lead them. That last statement is what motivated this study. This research will help non-expert users make educated decisions when selecting a mapping platform. Additionally, the scientific community will be able to quantify the difference between both platforms and determine the benefits of using one over the other. In summary, the purpose of this research is to assess the suitability of drones for their use in the mapping industry by comparing their processing software. For this experiment, I collected 81 images and processed them using drone and aircraft software. The images were collected using a 100 megapixel camera, which amounts to 100 million pixels, which is about 8 times more information than an image taken from your iPhone. Then, I used the data collected by a surveyor who drove to the study site and measured 6 physical locations with a GPS. Now, if you consider these measurements as the true values, then you can determine the accuracy of a processing software by comparing these field coordinates with the coordinates measured on the images previously collected. Here, we can see the software processing results. On the left, we have X, Y, and Z for a software representing drones, Pix for the mapper, and on the right, we have IMAT representing aircrafts. Next to each CP or checkpoints, which we have previously discussed, we have the difference between the value determined on site and the value determined from the images. A value of 0 would be ideal and it would mean a perfect match with no errors. At the bottom, you can see the root mean square error, which is kind of an average for each coordinate. Here our goal is to determine if drone software can achieve the same results as aircraft software. Here, this table shows the differences in pixels. If we compare the X coordinates, the drone software shows almost 2 times lower accuracy, and the Z coordinate, which is the elevation, about 4 times less accurate. This comparison of accuracies tells us how well drone software performs and therefore how suitable drones are for different mapping applications. The goal of this study was to assess the suitability of drones for their use in the mapping industry. And while drone software did yield less accurate results in my findings, drone platforms can still be used for many applications that do not require high accuracies, such as environmental monitoring. One limitation of this study is that it used photos captured with 100 megapixel cameras, and it would be beneficial to compare the results with cameras of different sizes. Finally, it should be noted that the simplified and highly automated nature of drones make them very attractive candidates as an alternate option for mapping. This conclusion reinforces the fact that we live in a complex world with simple solutions. Thank you.